Next we are going to see about speed control of DC shunt motor and starting method of DC motor. The speed control of DC motor can be achieved by varying the armature resistance and varying the field resistance. First let us see about the speed control by varying the armature resistance. Here the graph shown that the speed versus armature current. If the if the armature current increases, the speed decreases. So in the end, the armature resistance RA being small, the speed versus armature current characteristic will be straight line, a small slope instead. To make this to make this point clear, let us assume that load torque is constant at rated value. So from this initial steady condition, we have load torque rated TAN equal to K equal to IA rated. If the load torque remains constant, the flux is reduced. So new armature current in the steady state is obtained from KA1 equal to TL. So this method therefore will be suitable for load whose torque demand decrease with a rise in speed, keeping the output power constant. So starting of DC motor. The speed of machine cast the speed of machine has to increase from 0 to brought to the operating speed. This is called starting of motor. The operating speed itself should be varied as per the requirement of load. This is called speed control. Finally, the running machine has to brought to rest by decelerating the same. This is called braking. At the instant of starting, the rotor speed n equal to 0, hence the starting armature current I starting equal to V by Ra. Since the armature resistance is quite small, the starting current may be quite high, a large machine characterized by a large rotor inertia. So thus the level of high starting current may be maintained for quite some time as to cause serious damage to the brush commutator and to the armature winding. Also the source should be capable of supplying this burst of large current. Other load already connected to the same source would be experience a dip in the terminal voltage. Every time DC motors attempted to start with full load voltage, this supply voltage caused by due to sudden rise in the voltage drop in source internal resistance. So a simple starter is to limit the starting current. Suitably external resistance R is connected in series shown in figure with the armatures so that at the time of starting to have sufficient starting torque. The field current is maximum by keeping the external field RF is to 0 value. So the motor pick up the speed and the value of R is gradually decreased to 0. So that during the running no external resistance remains in the armature circuit, but each of time one has restart the motor, the external armature resistance must be in maximum value by moving the jockey manually. Next one is 3-point starter. The 3-point starter is essentially used to start the DC shunt motor. It is not only overcome the difficulty of plain resistance, but also provides additionally protective features such as overload protection and no load protection. The diagram 3-point starter connected DC shunt motor. Although the circuit looks like a bit of clumsy at everything. The starter is shown enclosed within the dotted rectangular box having three terminals A, L and F external connections. Terminal A is connected to the one armature terminal A1 of the motor. Terminal F is connected to the field terminal F1 of the motor terminal. L is connected to the one supply terminal. So the external armature resistance consists of several resistance connected in series with shown in. So the junctions of resistance are brought us to terminal mark. Then the working principle of in the in this position all the resistance in series is connected to the supply. So when the external resistance in the arm circuit less than the first time resistance, find out the supply strip. So currently in the way all the resistance will be left out when the armature toll reached. In this position the electromagnetic layer attracted by soft iron handle. So thank you.